Okay, in this part of the series, we will go over some key computing concepts that are relevant to the field of data science. Because as you may know, computers comes at the heart uh, of data science when it comes to data processing. So, starting with some processing and storage components. So, RAM, what is RAM? RAM, or simply random access memory, is the part responsible for storing the data that the computer is actively using so that it can be accessed quickly by the CPU or the central processing unit. Now here we can see the main characteristics of RAM. First, it's very fast. That's why it connected directly to the CPU. It's temporary, meaning that once we close the application or the program utilizing that data on the RAM, then that specific data will be lost. And third, it's volatile, meaning that whenever we shut down the computer or simply cut off the power from the computer, all the data on the RAM will be lost unless we moved it into a permanent storage device like hard disk or whatever. Another type of memory includes storage devices, and that includes hard disk drives and solid state drives. Right? Storage devices store much more than RAM. In fact, much more than RAM. However, they are much slower than RAM. So as you can see, there's a trade-off here between the two. Uh, Another characteristic is that they are permanent, meaning that the data stored on in these storage devices will persist even if we cut the power from the computer. Third major component is CPU, or the central processing unit, or simply the processor. The processor is the computer component responsible for taking instructions from programs and then perform certain binary calculations. All right. It's worth noting that the CPU is directly connected to the RAM, and therefore it directly communicates with the RAM. Why? Because data can be loaded quickly from the RAM, as opposed to other storage devices like hard disks. Okay, here is a diagram illustrating the data flow, or how these three major components communicate with each other. So let's assume that we had an Excel sheet called mytaxes.xlsx, and we opened that file using Excel. At that point, the data for that file will travel all the way from the storage device to RAM so that it can be accessed quickly by CPU later, right? Now, depending on the tasks that we conduct on the sheet, certain pieces of data will go to the CPU, and the CPU will perform calculations on these data, right? Once done, that data will travel back to RAM and gets displayed to the end user. Or if the user simply closed that Excel sheet and saved the results or save the current form of the data, then the data in that sheet will travel from RAM back to the storage device so that it can be accessed later on after we close our computer. So as you can see, data goes from storage to RAM to CPU, from CPU back to RAM, and then possibly to storage, depending on whether the user wants to save the data permanently or not. Here is a snapshot of an application on my Windows computer called the Task Manager, which basically reports the utilization of the different resources we have talked about. So in this example, given the applications I had opened at that time, as we can see, I was utilizing 30% of my processor or CPU, 86% of my memory or RAM. Memory is just another name for RAM, and 11% of my disk space or the storage device. And here uh, we can see the or more detailed view of the utilization by each application opened up at the time. So the takeaway here is to always be aware and considering of the different resources that you are using whenever you conduct any data analysis of any kind, because these resources are limited, so you should be wise in utilizing them. Now let's talk about software. Software is just a collection of instructions that tells a computer how to work. And software can be divided into system software and application software. System software includes things like background programs and operating systems mainly. Operating systems like Windows, Mac OS X, Android, uh, Linux, or whatever, right? Application softwares are softwares that allow the user to interact with them, or they simply allow interactivity. For example, we have Google Chrome is considered an application. Why? Because it allows you to surf the web by opening multiple tabs where you can visit different websites on those tabs. It allows you to make bookmarks. It allows you to view your history and many other tasks. Same thing for the application Word. It allows you to process Word documents, right? You can change, for example, the font size, the font type, the font color. You can add spaces, change the outline, etc., etc. And the same thing goes for the remaining applications. So when we say application, we mean a software that permits or allows interactivity with the user, as opposed to things like the operating systems or the background programs and many other types of system software. So make sure that you are able to make that distinction. Let's talk a bit about the operating system. The operating system is a software responsible for allocating resources for the different applications as needed. All right, so here in this diagram, we can see that the user will open up the application. And depending on the tasks conducted, the application will communicate with the operating system, asking for a certain amount of resources. And by resources, again, we mean the RAM, CPU, and disk, right? The operating system will reserve those resources, which are basically hardware, right? And then reports back in this loop to eventually show the results required for the user. So as you can see, the operating system acts as an intermediary between the different applications or programs and the computer hardware, right? Let's talk about download and install. These two terms are usually used interchangeably in the realm of IT, which is completely incorrect. Download is entirely different from install, right? Download is copying uh, software data from the web, from a CD or from a flash drive into your computer's storage device. Now, install is basically allowing that software to make configuration changes to your computer by, for example, creating shortcuts or placing certain files in certain locations and many other tasks. Right. So, for example, here I've took a snapshot of uh, the software install of a program called PuTTY, right? And as you can see during the installation process, it listed the type of tasks or things that will be done by the software. For example, install PuTTY files, add shortcut to PuTTY on the desktop, put install directory on the path for command prompts, associated PPK files with pathogen and Pidgint. So all of these, uh, although a little vague, include the different tasks uh, that are uh, being done during the installation process. Okay, Next, a programming language. A programming language is the language we use in order to write instructions for the computer to be executed. It's as simple as that. The same way person A instructs person B using the English language. In this case, we are instructing the computer to do something using a particular programming language. All right, that includes so many languages, like for example PHP, Ruby, Java, C++, Objective-C, and Python. Python will be the language mainly used throughout this series to introduce the different concepts. And it's just a programming language, just like many others. All right. Next, files and folders. What is a file? A file is simply a computer resource for storing data or information. Keeping in mind that data can come in so many different formats depending yeah, it can come in so many different formats, right? And depending on the data we want to store, different extensions and applications are used. So, for example, MP3 files are used to store music data, right? Doc files are used to store Word documents, right? JPEG is used to store image data. So you see, we have different extensions and different softwares used to store and process different types of files. The types of files depends on the data we want to store or process, right? A folder, as you may already know, is simply a collection of files. Nothing more to say about that. Next, the concept of file path. A file path is simply the series of folders and subfolders you need to go through in order to access a particular file, right? So, for example, if we wanted to access this particular file, then we need to go from the website directory to the applications 3 directory or application 3 directory to media and then access the file of interest. This concept becomes particularly important when we want to read data from a specific file in our program. In that case, you should be able to specify the correct path to access that file. Okay, next. A network. What is a network? A network is a collection of computers and other electronic devices connected with each other to allow data sharing. One part of the definitions that I want to emphasize is electronic devices, right? So uh, uh, the components in a network do not have to be necessarily laptops, all right? It can be, for example, a printer, it can be a refrigerator, an air conditioner, anything. As long as the that component can communicate with the other devices, then it can be a part of the network, right? Normally, the devices in a network are connected through things like routers and switches, right? Now, assuming that this laptop wants to uh, print out a document, and in this case, it will communicate through this router with the printer, right? It will send the Word document that it wants to be printed out by this printer, right? So as you can see, the devices are sharing their resources. The printer can print documents and the laptop can create the documents and process them, right? Same thing if this tablet wanted to change the temperature on the refrigerator, right? Or the smartphone wanted to do something with this air conditioner, then they simply communicate with each other through this network, right? Now, an important concept in networks is the IP address, all right? So the IP address is the a major identification mechanism of the devices in a network, right? And it normally takes this form, like 10001, for example, for this device, 10002 for this device, 10003 for this device. So whenever a device in a network wants to communicate with another in the same network or in any other network, then they should specify the destination IP address so that that device can be identified and therefore receive the correct data. All right. Okay, now the internet is simply network of networks. So in the previous example, we've talked about a private small network of a couple of devices, right? But what if one computer in a small network wanted to communicate with a device in another network in another part of the world? Then in this case, these networks must be connected in some way. And this is basically what constitutes the internet. All right. The internet includes the different devices, the network cables, the switches, the routers, the access points, the internet service providers like Verizon and AT&T and many others, and so on and so forth. So as you can see, the internet is a very big term that includes a lot of components in its architecture, right? So in this case, similar to the previous case, this device will have an IP address, right? Like 10.0.0.2, and it wanted to communicate with this device with the address 10.1.4.50, for example. In this case, this laptop will send its data to the wireless router. This wireless router will be connected to the service provider, like Verizon. Verizon will be connected with AT&T service provider through certain types of links, like fiber optic links. AT&T will be connected to the router of the other network, and that router will be connected with the destination laptop, which will receive the data sent from the original laptop. Similarly, different devices can communicate with each other through the same approach. Okay. Uh, Two terms that are usually used interchangeably are internet and the web, and they are completely different. The internet is, as we saw before, is basically a network of networks along with the many components we have mentioned, right? And the internet is basically used for data sharing, right? And data sharing is done through many approaches or methods. One of them is through the web or World Wide Web. So what is the web? The web is basically billions of digital documents connected to each other, right? Through hyperlinks. What do you mean by digital document? A web page. What a collection of web pages called is simply a website. So a website is basically a collection of web pages connected with each other. Through hyperlinks, we can navigate either internally within the same website or externally to different web pages in different websites. So that's basically the web. All right. Now, how do we serve the web? Using something called the web browser, like Google Chrome, Mozilla Firefox, Internet Explorer, etc., etc. Once we open up the browser, we provide the web address or the URL, the Unified Resource Locator, in order to visit a particular web page. So again, we provide the URL or the web address to visit a particular web page. How do we access that web page? By providing first the domain name or the website name, followed by the path to the web page of interest or the destination web page. So in this case, we are visiting the website nasa.gov, right? And on their website, right, we want to go to the topics folder. From topics folder, there's a technology folder. From there, there is a file called index.html. HTML is basically the markup language used for the web. Okay. Now, these here basically are probably some hyperlinks that we can click on in order to navigate to different parts of the website or potentially different parts of the web as a whole, right? So just make sure to understand the distinction between the internet, which is a much bigger term, and the web or the www. All right, next. A server. What is a server? A server is a computer with powerful resources used for serving data to other computers or devices, so they don't necessarily have to be computers. Now, people usually think of something complex when they hear the term server, which is not the case. The server is simply a normal computer, just like the one just like the one me and you use. However, that computer has more powerful resources under its belt. Why? Because it's going to serve so many client computers with limited resources like the ones me and you have, right? So, for example, we have this computer here requesting data from this powerful computer called the server. The same thing for this client here, the same thing for this client here. Now, we have mentioned before that the devices are connected to each other through networks, right? Uh, 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 so in this case, the server also will be part of a network so that it allows data communication between the normal computers with the limited resources with the server with the powerful resources, which in most cases will provide uh, certain types of data or simply services to the clients of different types. Now, there are so many types of servers depending on the application or the type of data at hand. So, for example, we have the web server. These servers are dedicated to serving web pages or digital documents, like we mentioned. In this case, we will have the web client, right? And we will have the web server, right? Let's assume we wanted to visit bmw.com, right? So in this case, this web client, assuming me through the web browser, will send a request to the web server of BMW. BMW server will process that request and then reply with a response to the web client. That reply will basically include the web page requested. In this case, it is index.html. Okay. Now, keep in mind that in many cases you won't be able to, you won't be the only client requesting data. There can be million others, right? Requesting data from the same server. Since that server is powerful, it will be able to satisfy all those requests. Another type of server is the email server, which is dedicated for serving emails, like Google's Gmail, for example, or Hotmail. Again, we have a client and a server. The client will request email and email services from the server, and the server will uh, satisfy those requests, right? Third, we have the game server, which is mainly used to synchronize the game status among the different players of the game so that they can see the same objects, the same scores, the same everything on their view of the game. So it basically synchronizes the status of the game. All right, so the takeaway here is that we have so many different servers, and in the future, in the data analysis or data science career, you will be utilizing so many servers to achieve so many different tasks. So make sure that you are comfortable with this concept from now. All right, that was it for this introduction. I hope you found it informative, and I will see you in the next tutorial. Thank you for watching.